Um, Good afternoon, guys. Uh, we have already set up the high voltage cable testing. So at this point in time, we are testing cables for primary side only. This is the primary side for MVSG cables going to now we are testing these cables going to transformer C. See, this is transformer C. So these are the cables, the end cables for transformer C we have subjected to test. Okay, so at a distance, if you see, this is for transformer C. These are the elbow connectors for transformer C, primary side. That is rated 34,500 volts. So this transformer C, this is transformer B, not yet, and this is transformer A, also not yet. Okay, so far we have tested cables, blue cables, and now ongoing is yellow cables. So for 15 minutes again, we are subjecting the cables for 55,000 volts in 15 minutes. So we will take about an hour, at least, not less than an hour, but an hour at least, 45 minutes to an hour at least in testing these three cables. So this is the setup again, guys, using the very low frequency tester and its accessories. So how many minutes na?
10 minutes, sir.
Oh, another 5 minutes more, guys. So just hold on. This is a dangerous site. Nobody can go near here because, you know, guys, 15 milliamps at rated 34,500 volts. Now it is injecting 55,000 volts. 15 milliamps is our passing. If you were say electrocuted by a 15 milliamps, that is very dangerous for our heart. It will instantly kill you. That will penetrate the weakest point in our body system. So the weakest point in our body is the heart, or whatever nerves we have in our body. That 15 milliamps is enough to kill anyone at 55,000 volts. So this is a very dangerous job, guys. So we are having a warning sign that nobody can enter on this area of testing. Only qualified people are here to witness it. And of course, we have advised also DOA to witness it. And they had confirmed. So guys, we have done this before, and the test we made was already, if you look at this first private pole, see, we have already laid out those cables. See, that cable is from here So that cable is to be terminated to this MVSG incomer side. Now it's going to the concrete pedestal. See, now it's laid out going to the first private pole on its recloser. You see, that's the recloser side, guys. So that cable already passed the very low frequency test. So that was done December 23. Now we are continuing for the rest of the cables. Remaining cables are for transformer A. Transformer A is there, transformer B is here, and ongoing tests are for transformer C. So transformer C, guys, because it's very near to the instruments now, and the next will be these three with plastic shielding, plastic cover. So that will be next. That is for transformer B, because the one inside the trench is there. That is for transformer A. So again, guys, this is for transformer A. Okay, the elbow connectors, primary side. Our supplier for this transformer under the leadership of the PDCC. So they will install here a cable tray and a transformer box cover. So this transformer A and transformer B will have its own cable tray here, secondary side also. Transformer B here will also have its cable tray. So that will be supplied by our third party, and it's transformer box. There will be a transformer box on the top portion of this transformer that will be fabricated. Okay, that will prevent splashes or water splash outside. So this will be protected against splashes of water. This is though outdoor, but still have to be covered because it's a bushing type. It is not compartmentalized type. So there is a transformer cover. Unlike this one, this transformer C is compartmentalized, so no need to have a cable tray or the transformer cover. Okay, so guys, I think we are finished for the yellow cable. Yes, the yellow cable now is about to finish. Okay, so now the cable for this yellow is as past, or the duration for the 55,000 volts duration is already passed. Now we have to discharge this cable. Okay, this cable will be discharged for residual voltage. Okay, na-discharge na ba?
Yes, sir.
Okay, may na ano? Hindi ko pa. Okay naman. So the last cable will be tested, will be the red cable. Yeah. So that red cable, the same setup. It will be subjected for another 15 minutes at 55,000 volts. Okay? So, okay. Only qualified people, guys, are allowed to enter this area. Remember, because if you go near,
Inject, sir.
okay, ready for injection. The area is clear. Okay. Okay. So guys, now we will wait for 15 minutes. If you look at the graph, guys, the graph trying to what is this? The milliamps or the leakage current is trying to go beyond the insulation of the cable, but it cannot push through. That's why the graph will look like this. So just looking like that. But it tried to, at a certain point, it tried to go beyond, but it cannot push through because it has a strong insulation, meaning the cable is good. But once it spikes to more than 15 milliamps, the cable looks deteriorated, or something failed inside the cable. The insulation failed, just like that. So we will see. That is why we have to be sure that all cables here is free from what is this? Pinholes, pinholes, or whatever external forces that cause the cable to deteriorate itself, that can be determined only by the injected voltage that we have. So the likeliness of this test is just like a hydro test in water testing. So in this test, we are determining whether there is a leakage, tulo, meaning leakage. The leakage current in terms of milliamps, in electrical terms, the leakage, we are measuring it in terms of milliamps, or the leakage current. Pero in tubig or in hydro test, we are determining it in terms of the volume of the water, or there is a residual leakage in the blinds, or in the what is this, joining sections. So if the bolt is not really tightened to its torque, we can determine that there are leaks in the water system. But in electrical terms, you cannot see where is that leakage came from. So in short, the weakest point in the system, at any point in the system, or at any point on the line of the cable, is as good as its weakest point, meaning the cable is as good as its weakest point. Just a single or a pinhole weakest point in the cable will determine that the cable already failed. And it's not like in the mechanical side, hydro testing, if there is a leak, it's very visible. So we can already determine where the leak is, whether the leak is from the joining point, or there is a weakest point in the surface of the metal. Then we can just apply some welding. Unlike in the cable, no. If we found the cable had a leakage current, the cable will be totally wasted. It will be replaced once we found that it failed from this test. Unlike in the hydro test, if we found some leak, we can repair it immediately. So this is how critical cable testing is. So again, this red cable is going to transformer C here, red from the transformer C. This is our transformer C, and that red, that's the end line of that cable being tested. So in here, nobody should come. Only qualified people will be roaming around in this area during the test. Nobody can enter here. Okay? So after this, these cables for transformer C is declared to be ready for energization. So we have completed the cable color blue and yellow, and red is line 1, yellow is line 2, and blue is line 3. Okay, that is how we have coded the cables. Red is line 1, yellow is line 2, and blue is line 3. That is our color-coded cables means. So, just for your information, guys, to those who have not yet witnessed this test, this is for your information, guidance, and initial data, because from this we can only say that the cables are ready for termination, and the cable is really okay for, because this is 34,000 volts. This is not a joke, guys. 34,500 cables should be subjected to this kind of test. This is no joke. So you must remember that whether you like it, whether it is costly, we have to spend some time, to spend some money for the test, because this is the only way to determine that the cables we have pulled, we have laid out, we have terminated are really ready for energization. This is the way to determine it. So another 15 minutes. Ilang minutes na, sir?
Mag 8, sir.
8 pa lang. Oh, sige. So we still have 7 more minutes, guys, to wait for the complete test of these 3 cables for transformer C. I just keep on talking to use the time for your viewing. You will not get bored. So this information, cable testing is similar to hydro test, wherein our purpose is to determine whether there is a leakage in the cable, in water or in piping system. We always perform hydro test because hydro test is the only way to determine that the pipes do not have water leak. But in electrical terms, we have to subject the cables to high voltage test. See, 34,000 against 55,000 injected. So it's more than doubled, guys, ha? It's almost doubled the rated voltage of the cable. In comparison to the piping, the water pipes is almost subjected to 6 times the water pressure of the pipe, even 10 times more, to let them prove that the pipes do not have its weakest point. So it means that the pipe or the cables is as good only as its weakest point. But the problem in cables, if the cable is found to be defective or failed, you cannot replace it just like the pipe. The pipe can be repaired, the pipe can be welded to repair the leak, because it is visible, the leak is very visible. But in cable testing, no. Nobody can determine where the leak comes from. So disposed, or meaning defective, that is to be replaced. And the cable is cost a lot of thousands, hundreds of thousands of pesos. So that is the difference between hydro testing and HIPOT testing, or high potential testing in electrical terms. So the difference now, we are using non-destructive testing, which is very low frequency. Former times we are using AC. Sometimes 34,000 volts times 3, that is almost 100,000 volts injected to the cables. That is very destructive before. But now, in a very low frequency, it's very low voltage being applied, but the 0.1 hertz will determine the very low frequency of the cable, will show the graph of the milliamperes that is injected, that is shown that the instrument had red inside. It's only that the instrument can somehow feel or describe what is happening inside the cable, and that is interpreted through the oscillogram, or the graph. The graph will determine it. So I have here, guys, our supplier from transformers, Ian. We are waiting for the cable tray and transformer cover. So after this, we will lay out the cable, and our purpose is not to put stress on the elbow of the cable. So we have to lay where the cable resides, wherein it does not create stress. So that is our professional or technical consultation from your side. So when is the available time, sir?
As of now, sir, the cable tray for the transformer A and B is still on
Fabrication.
for approval, sir.
For approval ba?
Yes, sir.
So this transformer, by the way, is not yet being degassed.
Yes, sir.
So we can expect degassing from this sir, transformer.
Yes, sir. The degassing and the oil filling, sir, is ongoing for scheduling. It might be
Done?
scheduled or done. We are currently ongoing interaction with our internal, sir. We are expecting to do it next week, early next week.
So I think this report is as good as saying to our boss that that activity will be done by the next week.
Yes, sir.
Uh, yeah, why can't we do it now? Yan, we have the oil already here. You have to inject nitrogen inside.
I guess,
What kind of
not yet, sir.
what kind of medium you are using?
That's for the gas and the oil filling, sir. I guess the nitrogen filling is
It's not recommended.
not recommended, sir.
Okay.
It's
So-
just for the scheduling of our manpower, sir.
Degassing means you are using external heater.
Yes, sir. External equipment.
Oo.
To the gas. I guess one transformer. I guess it will take up about 4 to 6 hours for the degassing.
So that will be mobilized maybe
Yes,
how
sir.
many days from now?
I'm checking, sir, for the earliest schedule of my manpower, sir, for the degassing and the oil filling.
So this is for your information, guys, that I thought we could have done it in parallel through this test, because the oil, transformer oil are ready now. So I thought we could do it in parallel to reduce our lead time. Maybe if we could do it for the week, then it would be better. But as discussed, still have to mobilize these external machines to be used. This is subject for ano, sir? Sir,
Yes, sir.
this is subject for a test. Baka lumapit ka. Okay. So, guys, we are awaiting for these transformers to be filled with lubrication oil, but cannot be done for the week. So that is beyond our control, because we have to abide by their schedule. If that is, the cable trays and the transformer box are still for approval and for fabrication. See, okay, I think we have completed, guys. Now you have not witnessed how they discharge it. On the next video, maybe I could demonstrate how they discharge the cables after the test. Because if you did it, you will notice some sparks due to the residual voltage remaining in the cables, or the capacitive effect, as we injected high voltage. So that is already discharged. We can touch the cable at any time. We are safe because these cables are already discharged. Now we will go to another setup, guys, which is transformer B. So these cables, before going that, I have not told you that we have conducted, prior to this test, we have conducted continuity test. So the cables are really confirmed to be from one end to the other end. That is confirmed. The second is we have conducted the insulation resistance test as an initial test. So we have recorded a lot of initial IR tests. There is an initial IR test for 1 minute. Every 1 minute, we have recorded initial tests for the insulation resistance test until we get 10 minutes. So 10 minutes over 1 minute, that will be defined as polarity index. So that is uh, an integrated data that will be calculated from the data we have gathered. So 10, 10 initial resistance tests will be recorded. And this is now the final IR test. So before conducting the test, I say that we have conducted the continuity test, we have conducted the IR test before, so 10 critical points or critical minutes. We have that. As a result of that, we can create the polarity index result. So this is the same. That initial test will also be applied the same to this final initial resistance test. So now we are recording now what is the final final insulation resistance test. Meaning, if is there really a failure after we have injected the cables? That is how we consider the test, because that will also help us in determining that the cable is okay by gathering some information after we have injected. So the final insulation resistance test will also help us judge or help us determine if our cables really are good. So we have to get the data. Final insulation resistance test after testing the cables. So guys, I have to cut short. I think this video, just for your information only guys, this data will still be translated into a technical report. This is just for your information and for your reference that we are conducting it in a legitimate manner. Okay? So we have the right people conducting this test. We have the right instruments. Calibration test certificates are proven to be updated. We have the right people, the right instruments, with the right accreditation. These people are TESDA accredited. So we have the certification also from these people. Okay? They have the right job, the right tools, and the right qualifications. Okay, I think I have to cut short this video guys. Again, this is just for your information that we have conducted this test. Still a lot of cables to be tested. See, we have just finished transformer C cables. 3 cables, almost an hour. It took an hour for the test, excluding the setup time. So we have already consumed almost 1 hour and 30 minutes in conducting this test. So another 15 plus 15, another 45 minutes is coming guys for this test. 15 minutes each cable. So that is 45 plus setup time. So let us say 1 hour. 1 hour for this test. These 3 cables only. So now transformer B. So this is transformer A. We are now subjecting or having a setup for these cables. Transformer B. May ano pa sir? May cellophane pa. Walang problema?
Hindi pa namin yun, sir. Ano pa to, sir?
IR pa pala. Oo nga pala. So these cables will be this will be removed, and be subjected to the next test. The same test or the same 55,000 volts will be injected on these cables. This is the primary side of this transformer B. This is transformer B. Primary side, elbow connected. Okay? That is 34,500 volts primary side. So now, still on transformer C, final insulation resistance test. So final insulation resistance test, meaning in final in an insulation resistance test, the cable is subjected to 10,000 volts DC in 1 minute. Okay, that is DC, and our passing for that is 100,000 mega ohms. But the reading, if you see the reading, guys, that is 556 giga ohms. See, it's more than passing for the cable, because the passing for the cable under the initial resistance test is 100,000 mega ohms only, but the results are 556 giga ohms, more than passing. So guys, I think I have said enough. The process will be repeated for the rest of the cables, and I have here Sir Edwin from DOA and the rest of the witnesses. So no problem with our witnesses. That is validated. The data we have gathered are validated, verified on the site, and subject for signing off. Okay. So we have completed transformer C cables, and that is for now, guys. We will go to transformer B cables adjacent to these cables. So that is for transformer B cables. We are now setting up for the next test, transformer B. We have completed transformer C. Okay, thank you guys, and I hope you have enjoyed this video. Thanks for viewing. Thanks for the information that we have gathered in the site, and this is all for now, guys, and we will update you on the technical report. The final technical report will come. So that is a form of test records that will form as a test records. So okay, okay for now, guys, and we have consumed this report for around 40 minutes. Thank you, and this is for your reference only. Thank you. Bye bye. Thank you.